Okay, today we're going to talk about radicals and rational exponents. A radical expression is a square root, a cube root, fourth root, etc. For example, this is the fifth root of 3. The index is the little number in the crook of the radical. In this case, it's the 5. A radicand is what's underneath the radical. In this case, it was the 3. A radical expression is in simplest form when the radicand has no perfect nth root factors, the radicand contains no fractions, and no radicals occur in the denominator. Some examples of this. Square root of 144b squared. This is assumed to be a little 2 in the corner for the index. If there's nothing there, that's the most common one, so we don't have to write it. Square root of 144 is 12. Square root of b squared is the absolute value of b. Since this is an even index, it has to have an absolute value. And the second one, if you square root this trinomial, factored is 2m minus 1 quantity squared. The square root and the squared will cancel each other off. That leaves you with 2m minus 1. And since, again, this is an even index, that's going to be an absolute value. 125, on example 3, you can break down to its primes. 5 times 25, and 25 is 5 times 5. So that means when you're taking the cube root of negative 125, that's like negative 5 3 times. That's negative 5 cubed. And then a to the 12th is a to the 4th cubed. So each of these are perfect cubes. So you can take the cube root of taking each of those out. The cube root of the negative 5 cubed is 5. And then the a to the 4th also comes out. When you're looking at properties of radicals, when you're looking at two things underneath multiplied together, you can separate them into their individual radicals. So each of these is the nth root of a and the nth root of b. If they're already separated into their individual radicals, you can put them together underneath one radical as long as the index is the same. In this case, you can take the cube root of 16 and the cube root of m to the 5th separately. Oops. And then you can break this down. 16 is 2 times 2 times 2 times 2. M to the 5th, there's 5 of them. If you're thinking cube root, you're pulling them out in groups of 3. So 3 of these 2's come out. One of them is still left underneath the cube root. 3 of these m's come out as 1, and then there's 2 still left underneath the radical. Now putting it back together, since they're all separated, you can take the 2 and the m and multiply it together, and underneath the cube root, the 2 and the m squared can go back underneath together. If you're looking at the division problem, you can put those underneath an individual radical also. So the nth root of a over the nth root of b. Also, you can have, if it's already separated into their individual radicals, you can put it back together as one big fraction under one radical. In this case, it's under one fraction or one radical. We can separate it into their individual radicals. So the fourth root of 32 is over the fourth root of 81. 32 is 2 to the 5th, or you can think of it written out 5 times. And 81 is 3 to the 4th, or you can write it out 4 times. And again, this index is 4. You should be thinking in groups of 4 can come out. So 1, 2 comes out, and there's an individual 2 still left underneath that radical. And then 4 of the 3's can come out as a 3. The last thing we have is rational exponents. By definition, rational means any number that can be written like a fraction. So rational exponents are fractions that are in the exponent position. So in this case, the m over n is a fraction that's in the exponent. You can rewrite this as m is what you're raising the whole thing to, and n is the root. So the n goes on the outside. The number on the top of the fraction goes on the inside of the radical. You can also write this as the nth root of a, all being raised to the m power. For example, 27 to the 3/2 power, the 3 is on the inside of the radical, the 2 is on the outside of the radical. In this case, this is a square root. Again, you don't have to write that as the index. It's automatically assumed to be that. 27 is 3 cubed, which is being cubed. That means it's the square root of 3 to the 3 times 3 as the powers is 9. And you can think of that as 9 3's all written out, or you can think in groups of 2 they come out. There'd be 8 of them that can pair up, as 4 of them that come out of the radical, and there's still a 3 left underneath the radical. And 3 to the 4th is 81, and 3 is still left underneath a square root.